Welcome to this focused deep dive. Crafted specifically for you, the Cambridge International A-Level Computer Science student, getting ready for the 9-6-18 Paper 3 exam this June 2025.
That's a big one.
It is. We know this advanced theory paper, covered in chapters 13 through 20, can feel like a significant hurdle.
Definitely.
So our mission here is pretty straightforward. Equip you with a clear understanding of its structure, highlight essential patterns from recent exams, maybe offer some well-informed predictions for your test.
Fingers crossed on those.
Exactly. And share practical prep techniques, arm you with crucial exam strategies. Think of it like your express route to what really matters.
Good way to put it.
And importantly, before we even dive in, we want to point you towards some fantastic resources from Zafar Ali Khan, Zach.
Oh yeah, Zach's stuff is brilliant.
Absolutely. You'll find tons of in-depth explanations on Zach's YouTube channel. His website, that's www.kazwithzach.com. It's just packed with materials.
And the AI assistant.
Right. For truly personalized help, like 24/7, there's AskZ, Zach's AI teaching assistant. It's incredible. It tutors you in all subjects, any language.
Seriously, any language.
And it's right there on WhatsApp. Plus 923-3628-10241. Or use the link, bit.ly AskZ chatbot.
So helpful for those tricky spots.
Definitely. Remember, success in Paper 3 is well within your reach with the right knowledge, the right approach. And that's what we're here for.
Let's get into it.
So let's start by unpacking the fundamentals.
Yeah.
What exactly does Paper 3 look like?
Okay, so Paper 3, like you said, it's the advanced theory paper. It's a written exam, 1 hour, 30 minutes long, and it's worth 75 marks for your A-level.
Just A2 content. Yeah.
Exactly. Crucially, it only tests chapters 13 through 20 of the syllabus, just the A2 stuff. And yeah, traditional pen and paper, no computers involved.
And answers are mainly pseudocode and explanations.
That's right. Mostly structured pseudocode and formal explanations. You will definitely need to write algorithms in pseudocode, but you won't be executing or compiling actual code.
Okay, and the format. Lots of questions.
Typically around 8 to 11 compulsory questions. Each one usually has several subparts, so, keeping an eye on the clock is going to be important.
That's a key point, especially thinking about Paper 4. Could you maybe highlight the main differences in what they assess?
Sure. So Paper 4, the practical programming paper, that one focuses on sections 19 and 20. But, and this is important, it specifically leaves out low-level programming like assembly language and declarative programming, logic programming.
So those are P3 only.
Precisely. Those two areas, assembly and declarative, they're uniquely assessed in Paper 3. So if you're thinking about assembly language questions or maybe some in prologue style, P3 is where you'll see them, not P4.
But some topics overlap.
Yeah, some do. Higher level concepts like object-oriented programming and recursive algorithms, those can pop up in both. In P3, it'll be written exercises, pseudocode tracing maybe, whereas in P4, it's actual coding challenges.
Okay, so low level and declarative are the big P3 exclusives. That really helps clear things up. So considering that A2 syllabus, chapters 13 to 20, what specific topics should students really be focusing on for Paper 3?
Right. Well, the syllabus for those chapters is pretty broad. Chapter 13, that covers data representation, things like the nitty-gritty of binary floating point numbers, different ways to organize files.
Floating point always seems to catch people out.
It can do. Then Chapter 15 jumps into computer architecture, comparing RISC and CISC processors, looking at machine-level operations, plus the essentials of Boolean logic and circuits. Very important, that one.
Logic gates and K-maps.
Exactly. Chapter 16 is System Software OS, translators. Chapter 17 is security, so encryption, network protocols.
Getting very relevant now.
Definitely. Chapter 18 introduces AI graphs, neural networks, machine learning concepts. Chapter 19 is all about computational thinking, advanced algorithms, ADTs, recursion.
The real problem-solving stuff.
Pretty much. And finally, Chapter 20 brings in more programming paradigms. Low-level assembly, object-oriented, declarative, plus file processing and handling exceptions.
Wow, okay. It really sounds like Paper 3 needs both solid theory knowledge and the ability to apply it just on paper. What kind of questions pop up most often?
Yeah, you'll generally find a mix. Some are explanation-based, describe how this works, explain that principle. Others are more application-based.
Like writing pseudocode.
Exactly. Writing algorithms in the syllabus's specific pseudocode style, analyzing a given scenario, maybe doing some calculations related to a concept. Being comfortable with that official pseudocode guide is absolutely vital.
But no actual Java or Python coding needed here.
Nope, none at all in paper 3. It's all about showing your understanding through that pseudocode and clear written explanations. Familiarity with programming helps, of course, but it's not about writing runnable code.
Gotcha. And think about how they mark it, which assessment objectives, the AOs, are most relevant for P3.
Okay, so paper 3 mainly hits AO1, which is your knowledge and understanding, and AO2, which is application and analysis.
And the weighting, is it even?
Not quite. It's roughly 60% AO1 and 40% AO2. There's very little, basically zero emphasis on AO3, which is synthesis and evaluation.
So breaking that down, what does that 60-40 split actually mean for the types of questions you'll face?
Well, with that weighting, you should expect a good chunk of the exam, the 60%, to be about recalling and stating facts, defining key terms, describing how a process works, that kind of thing. AO1.
Standard knowledge recall.
Right. But then the other 40%, the AO2 part, tests if you can use that knowledge in new situations. Writing pseudocode for a task, analyzing a problem to pick the best approach, doing calculations based on principles you've learned.
But less about designing whole new systems.
Exactly. Paper 3 typically won't ask you to design complex new systems from scratch or do big open-ended evaluations comparing different methods. Those kinds of tasks, they lean more towards AO3, and you're more likely to see them in paper 4.
Okay, that paints a really clear picture of what paper 3 is targeting. Brilliant. Now let's shift gears and look back. By digging into recent past papers, say from June 2022 up to June 2023, what key trends can we spot? Maybe start with communication and networks, Chapter 14.
Okay, yeah, looking at those recent papers, Chapter 14, Communication Networks, it's definitely irregular. There's been at least one question in each of the exams we looked at.
Consistent, then.
Very. What's interesting, though, is how the focus kind of shifts between subtopics. One year, it might be protocol layers, especially TCP/IP.
Like the different layers and what they do.
Exactly. Naming protocols like HTTP, IMP, explaining their purpose. June 2022, for instance, asked about the general purpose of protocols, the TCP/IP layers, naming protocols for layers, explaining their roles. So understanding that layered model is key.
And June 2023 went a bit different.
It did, yeah. June 23 shifted focus more towards circuit switching versus packet switching, asking for examples where packet switching fits better, exploring the core differences in how they work.
How many marks are these network questions usually worth?
Typically around 6 to 8 marks. The style varies. Sometimes it's straightforward knowledge recall, like matching things or listing differences. Other times it's more scenario-based, like identifying the switching method used.
So it's not just memorizing protocols.
No, definitely not. The trend suggests you need to understand the why behind the methods too, circuit versus packet, the architectural choices.
And you mentioned newer tech creeping in too.
Absolutely. Good example. November 2022 had a question touching on SSL/TLS and digital certificates. Now that links heavily to security, Chapter 17, but seeing it in a networking context shows how interconnected things are.
And the importance of network security now.
Precisely. The main point with networking questions seems to be understanding why methods are used, that's your AO2 application, as well as just what they are, the AO1 knowledge. So be ready to identify protocols, explain layer functions, or compare techniques concisely.
Okay, good advice. Moving on to another area that crops up a lot and often carries, well, quite a few marks. Boolean logic and circuits, Chapter 15.2. This seems super important.
Oh, absolutely right. Boolean logic and circuits, very common, often chunky marks involved. Cambridge tests this in a few ways.
Like writing expressions.
Yeah, writing or simplifying Boolean expressions from scenarios. June 2023 was a prime example. They gave a full truth table, asked for the sum of products expression from it.
Okay.
And then, crucially, you had to use a Carnot map, a K-map, to simplify that expression right down. That whole multi-part question was worth 10 marks.
Wow, 10 marks. So K-maps are a big deal.
Definitely highlights their importance, yes.
But it's not always that complex, is it? Sometimes it's more foundational.
True. Earlier papers sometimes have more basic stuff, like interpreting logic gate diagrams. June 2022 had a simple circuit, basically a half-adder, and asked for the truth table, its name, and the purpose of the outputs.
Testing the basics.
Exactly. Those test fundamental understanding, usually worth fewer marks, maybe 4 marks in that case. K-maps are more about the optimization side. Think of them like finding the simplest route on a map, but for logic.
You mentioned K-maps again.
Mm-hmm.
Sounds like a definite trend.
It certainly looks like it. The emphasis on using K-maps for simplification is notable in the newer syllabus. They expect you to apply these techniques.
What about things like flip-flops?
Yep, they get tested too. SR, JK flip-flops. October, November 2022, for instance, asked students to draw an SR flip-flop circuit, state its purpose. That paper also had Boolean algebra simplification using De Morgan's laws.
So, multiple ways to simplify.
Right. The fact they test both algebraic simplification and K-math shows a strong focus on optimizing expressions. That's a key AO2 skill using different methods.
Okay, let's switch to security, chapter 17. That field changes so fast, I guess the exam content has to keep up.
Absolutely. Security questions have definitely evolved, bringing in more current topics. June 2022, we saw digital certificates and signatures, how you get a certificate, how signatures are made and checked using encryption.
Well, practical application of crypto.
Pretty much. Then Ocnov 2022 carried on with encryption protocols, specifically SSL/TLS, and the role of digital certs in secure comms.
Like HTTPS.
Exactly. By June 2023, the focus broadened a bit general crypto methods, explaining the purpose of quantum cryptography, which was quite new to the syllabus then.
They tested that quickly.
They did. And also comparing symmetric versus asymmetric encryption.
So they're definitely testing the newer stuff.
It seems so. The quantum crypto question appearing soon after it was added really shows that. Security questions tend to be shorter, maybe 5-6 marks total, but they demand precision.
Like knowing definitions.
Yes, definitions of public-private keys, digital signatures, and comparisons symmetric versus asymmetric, but also the why and how purpose of TLS, steps in verifying a signature. That's key.
So expect something on crypto or network security protocols.
That looks like a very safe bet, yes.
Right. Now, let's tackle what many find challenging, but is, well, totally central to CS. Algorithms and problem solving, chapter 19. Pseudocode central, obviously.
Oh, absolutely. Algorithms and problem solving, that's the heart of P3's application side. You can bank on seeing pseudocode questions in every single exam.
What kind of tasks? Searching and sorting.
Yep, frequently. Writing, tracing, modifying search sort algorithms. June 2022, for example, had you complete a linear search pseudocode, explain when binary search works and how it operates.
What about sorts like bubble or insertion?
They weren't explicitly on the recent P3s we reviewed, but they're definitely in the syllabus, so it could absolutely appear in a similar format. Completing code, tracing, explaining.
And abstract data types, ADTs, stacks, queues.
Big role there, too. Cambridge often includes questions on using or implementing ADTs, like stacks, queues, linked list, binary trees.
Any recent examples?
Ocnov 2022 had a hefty linked list question. Gave a representation, had you update pointers after deletes, then write pseudocode to traverse the list. That was quite involved, AO2 heavy, about 10 marks.
And June 2023.
Shifted to a circular queue ADT. You had to complete the initialize and enqueue pseudocode, and crucially explain why a queue beats a stack for managing print jobs.
So they alternate between different ADTs.
Looks like it, yeah. Linked list, then queue suggests they aim for broad coverage over time, so don't be shocked if stacks or maybe binary tree stuff appears next.
Interesting. What about recursion? It's in chapter 19, fundamental concept.
Yeah.
But has it featured much?
That's a really sharp point. Recursion is core, syllabus expects you to get it, trace it with a stack. But it hasn't been a major focus in the 2022-23 papers we looked at.
Maybe it's due then.
Could be. Its relative absence might mean it's lined up for more attention soon. A question tracing simple recursive code or writing a basic recursive function like factorial seems plausible. Definitely worth reviewing thoroughly because it hasn't been seen much recently.
And complexity, big O notation, also in chapter 19.
Right, syllabus mentions comparing efficiency using big O, but again, it hasn't been directly, quantitatively tested in these recent papers. Haven't seen questions asking what's the big O complexity of this.
So maybe just conceptually?
Possibly. You might get a question asking you to conceptually compare two algorithms, explain why one's better for huge data sets. That would indirectly test big O understanding as AO2 application, but the main focus is definitely writing the pseudocode itself.
Okay, let's move to programming paradigms in chapter 20. Covers low-level declarative OOP.
Exactly. And remember, low-level assembly programming that's assessed only in paper 3. But quite noticeably, direct assembly questions were missing from the 2022-23 papers we reviewed.
Really? None at all?
No writing or tracing assembly code. Now, it could have been in the 2024 paper, or it might be due a big return in 2025. The syllabus covers addressing modes, writing basic low-level code.
And older exams had it.
Often, yes. Tracing, modifying assembly. And the current pseudocode guide even defines a simple assembly syntax. So we strongly suspect Cambridge will use it. Be ready for questions interpreting short routines or completing simple assembly tasks.
What about declarative, prologue-style logic programming?
Also unique to P3 assessment, it did appear in June 2022, a full question. Gave facts, asked for rules, clauses, interpret query output. Very prologue-like.
But not in 2023.
Didn't see in the 2023 papers, no.
Gotcha.
Suggests it might alternate with assembly. Questions usually involve reading, writing facts and rules, understanding query results, AO2 application again.
And finally, in Chapter 20, file processing and exception handling.
File handling pops up, but usually within other questions, like data structures. That June 2023 Q question involved reading patient records from a file, open file, read file, checking EOF in a loop.
So know the basic file operations.
Yeah, the expectation is, the fundamental pseudocode for file I/O, maybe complete code that reads or appends, usually integrated, not a standalone focus.
And exceptions, error handling.
Less obvious in recent exams. A theory question on the definition or benefit is possible, but it hasn't been a major feature recently.
Okay, so summing up the trends from recent P3s. Broad topic coverage, mix of theory and application, data rep, logic circuits, algorithms, ADTs, or regulars, networking, security also consistent.
That's right.
System software and paradigms maybe a bit less frequent or alternate. And newer stuff like AI, quantum crypto gets integrated pretty fast.
That's a spot-on summary. Examiners clearly aim to cover the whole syllabus over a couple of years. We're also seeing maybe more integration security with networks, AI concepts cropping up, and a consistent expectation you handle formal notations, K-map, pseudocode, maybe even BNF.
Right. Based on all those really insightful trends, let's move to the crystal ball gazing. What are your informed predictions for the June 2025 Paper 3 exam?
Okay, prediction time. And the usual disclaimer. These are based on patterns, no guarantees, right?
Yeah.
But we can categorize things high probability, medium risk, maybe some speculative ones.
Let's hear the high probability ones first. What feels very likely?
Okay, number 1, binary floating point and data representation from Chapter 13.3. It comes up so often. Expect normalization, conversion, maybe issues like precision loss, overflow, underflow. Could be comparing formats or explaining why some decimals aren't exact in binary. File organization or hashing might return too, probably around 5 marks here. Second, Boolean algebra and simplification, Chapter 15.2. Almost certain. Simplify an expression algebraically or K-map. Design a circuit from a truth table or scenario. Flip-flops possible if not in June 24.
K-maps again.
Very likely. Maybe derive some of products from a table, then simplify algebraically. Get comfortable with truth tables, gate symbols, deriving expressions, Boolean laws, and definitely 34-variable K-maps. They might explicitly say, use a Carnot map.
Okay, what else is high probability?
Third, networks, packet versus circuit and protocols, Chapter 14. At least one question. Since switching was recent, maybe it cycles back to TCP/IP layers or specific protocols like HTTP, FTP, SMTP.
Or network security.
High likelihood of that, yeah. TLS, public key encryption within a network context. So be ready for either switching methods or protocol layers functions. Protocols might be slightly more due. Fourth, security cryptography differences and uses, Chapter 17. A security question feels highly probable. Symmetric versus asymmetric differences fundamental. Digital signature asserts likely if not in June 24.
How are they asked that?
Explaining creation verification of a signature, or why HTTPS needs a certificate. Quantum crypto's purpose was asked, maybe drawbacks next, or stick to basics. Don't forget simpler stuff like virus versus worm, but encryption's a safer bet. About 5 marks. Fifth, and this is guaranteed, algorithms and pseudocode writing, Chapter 19. You will write pseudocode.
Search or sort?
Could be. Binary search if linear was recent, or vice versa. Insertion merge sort, possible. Maybe write a simple sort or trace one. Also likely, implement an ADT operation.
Like stack or linked list.
Given recent Q-linked list focus, yes, stack, push pop, or more linked list work, insert delete seems probable. Binary tree traversal less likely but possible. Stacks link nicely to recursion too. Might sneak in as a 1-2 mark part, asking for time complexity. But focus mainly on writing the pseudocode correctly. Finally, sixth, high probability. Programming, paradigms assembly, or declarative, Chapter 20.1. At least one seems very likely. If assembly hasn't shown up by June 24, it's really overdue for June 25.
What kind of assembly question?
Trace code, write short routines addressing modes. If June 24 did have assembly, then June 25 might lean declarative. Prologue-style fax rules, interpret queries, could even see both, prepare for one or both, maybe 4 to 6 marks combined.
Wow, okay. Those are some solid bets. What about medium risk predictions? Possible, but less certain.
Right, medium risk. First, operating system scheduling and memory management from Chapter 16. If recent papers skipped OS, the next might hit scheduling algorithms, paging versus segmentation, purpose of interrupts.
Scheduling seems plausible.
It was seen late 22. If not in 24, stronger chance for 25. Comparing algorithms, how OS handles multitasking, virtual memory, paging segmentation, also possible. I'd lean slightly more towards scheduling than paging for June 25. Know the methods in OS use. Second, medium risk. Virtual machines and parallel processing, Chapter 15.1, VMs and pipelining have appeared. A question on CISC versus RISC differences is quite possible, compare contrast.
What about parallel architectures?
AskZ SIMD, less likely, given recent coverage, but know them. Massively parallel computers, multi-core benefits, probably less likely as a main focus. Other hardware bits like interrupts, cache are less likely on P3. RISC versus CISC feels higher probability within this category if not asked by 25. Third, medium risk, machine learning specifics or AI ethics, Chapter 18. AI questions so far were factual learning types. Maybe they'll ask for an example AI use or how neural nets help ML. An open question on a real-world AI app and its technique is possible.
But maybe less likely.
Probably more likely they stick to the well-defined tasks we've seen already. Yeah.
Okay. And the long shots. Risky or speculative predictions?
Risky speculative. Exception handling and errors, Chapter 20.2. Not seen much explicitly. A definition or benefit question is theoretically possible. Small marks, 2-3 maybe.
Any major curveballs expected? New syllabus stuff?
No major syllabus changes for 2025.
Yeah.
All the new stuff, AI, quantum, K-maps seems integrated now. Don't expect huge surprises beyond maybe different combinations or scenarios using existing content.
That's a really useful breakdown. And maybe a rough guess at mark distribution.
Okay, very rough guess for 75 marks. Maybe 5 data reps, 6 networks, 8-10 logic, 5 security, 4 AI, maybe 10-15 on algorithms ADTs, 4 OPOS key concepts perhaps, 4 or 5 architecture like RSC CSC, 5 OS translator, and 4 Hay6 combined for assembly prologue.
Brilliant predictions, thank you. It's so valuable to know where to maybe focus that final revision push.
Yeah.
Now let's talk crucial exam strategies. What advice do you have for students, both before the exam and during it, how to prepare effectively?
Okay, effective prep needs structure. First, plan your revision order for chapters 13-20. A logical flow could be start with hardware logic, CH15, then algorithms paradigms, 19 and 20, then data rep, 13. Follow with communication security, 14 and 17. System software 16, and finish with AI 18.
And practice questions alongside.
Crucial. Interleave chapter revision with relevant past paper questions. Solidifies understanding, builds application skills, identify weak spots, early recursion, assembly, whatever, and give them extra time. Second, use the assessment objectives, AO1 and AO2, to guide study depth. For every topic, check. Can you define key terms, AO1? Can you apply it to solve problems, AO2? Use recall quizzes for definitions and plenty of problem-solving exercises, especially pseudocode writing. Third, focus intensely on command words and questions. Understand, explain, describe, write pseudocode, complete, trace, dry run. Practice answering questions with different commands, and really study the mark schemes to see the expected style and detail.
Mark schemes are key then.
Absolutely invaluable. Fourth, use past papers and mark schemes extensively. Last 3-5 years, ideally. Treat full papers as mocks. Practice topic-specific questions. Use mark schemes as learning tools, model answers, common errors, mark allocation, note recurring themes. Fifth, don't ignore the official syllabus and other resources. Use the syllabus for content depth. Check the teacher guide, the pseudocode reference. Ask teachers or online forums if stuck. Use textbooks, tutorials for tricky bits. Make sure you know the right level of detail for newer topics like AI.
Not too deep, not too shallow.
Exactly. Finally, simulate exam conditions regularly. Do full papers under timed conditions. Build stamina, helps time management. And maybe make a simple pre-exam checklist. Stationary, know the time location. Reduces last-minute stress.
Those are some really solid preparation tips. Now, what about during the exam itself? On the day, how can students maximize their performance in that 90 minutes?
Right. During the exam, time management is king. First thing, note the time, 90 minutes. Roughly allocate time per question based on marks. About 1.5 minutes per mark is a decent guideline.
And if you get stuck?
Don't dwell. Is stuck, mark it, move on, come back later if time permits. Crucially, leave some time at the end for review. 5 minutes, maybe? Second, tackle each question systematically. Really decode what's being asked. Read it carefully, maybe twice. Underline key requirements, command words, details, constraints. Break down multi-part questions.
Land technical questions.
Good idea. For assembly, K-maps, break it into steps. For algorithms, maybe quickly jot an outline in rough before writing the full pseudocode. Third, manage time during the paper. Keep checking the clock. If falling way behind, adjust. Maybe focus on higher mark questions you can do. Try not to leave anything blank. Even a partial answer can score points. Fourth, writing effective explanations, descriptions. Be concise, factual. Use proper syllabus terminology. Structure advantages, disadvantages clearly, even without bullet points, new lines, connectives help. Fifth, writing effective pseudocode. Plan complex bits first. Follow pseudocode conventions, strictly assignment arrow, logical ops, indentation, array indices. Comments help if time allows. Double-check logic and syntax before moving on.
Easy mistakes to make under pressure.
Very easy. Sixth, using diagrams. Neat diagrams for logic circuits, maybe syntax diagrams. Use correct symbols. Ruler helps for grids. Truth tables, K-maps. Seventh, review and final checks. Quickly reread answers. Check completeness, all parts answered. Logical flow. Obvious errors like missing NDF, uncalled functions, forgetting a reason, justification.
Turn the mindset.
Finally, eighth, stay positive and calm. Don't let one tough question derail you. Each is separate. Trust your preparation. Breathe.
Incredibly practical, reassuring advice for the exam room. So to wrap it all up, could you give us your top 5 essential tips for success in P3? A final motivational boost.
Absolutely. My top 5 for P3 success. 1. Master the basics. Rock solid understanding of definitions, concepts, principles. It's the foundation for everything else. 2. Practice pseudocode every day, or very regularly. The more you write it, the better and faster you'll get under pressure. Crucial for algorithm questions. 3. Understand command words. Know exactly what each command word demands in your answer. It guides the depth and style needed. 4. Review past papers strategically. Don't just do them, analyze them with the mark schemes. Learn from model answers and common mistakes. Spot patterns. 5. Stay calm and systematic in the exam. Approach it methodically. Manage time. Read carefully. Don't panic. Stick to your strategies.
Fantastic advice. Paper 3, yeah, it can feel daunting, but like you've shown, structured prep, really understanding the core ideas, and a careful exam approach make it absolutely beatable.
It's about solid understanding and applying it carefully, not just tricks.
Exactly. Remember all the work you've put in, feel confident in that preparation.
And for that ongoing support, please don't forget Zach's resources. Check out Zach's YouTube channel for detailed walkthroughs and his website, www.caswithzach.com, for loads of materials.
The AskZ AI assistant?
Yes. For personalized help 24/7, any subject, any language, AskZ is there on WhatsApp at +923 3628 10241, or use the link bit.ly AskZ chatbot.
We really wish you all the very best of luck in your upcoming Cambridge International A-Level Computer Science Paper 3 exam this June 2025.
Absolutely. And maybe a final thought to take away. Think about how these sometimes abstract theoretical concepts we've discussed today, they're actually the fundamental building blocks for the entire practical world of computing you'll meet in your future studies and careers. Getting these fundamentals right now, it's an invaluable foundation for everything ahead.